Cool. Right. I don't know how long this is going to be. I have some more specialist practice to do. Let me just mute myself in Discord. Yeah, so I fixed it. I had some issues with my audio. And I'm recording this, I'm not streaming this. Maybe one day I'll stream. Anyway, let's get on with our work. I'll start by kind of explaining what I've done so far. Let me just hide that quickly. So, before, so this is what I've done so far. This is what we've done in the tutorial to program kind of WASD movement as well as looking around in the 3D world. But if we comment all that out, I had all this commented out before. And with it all commented out, this is the player script on our player object. And we have our player in our temporary level here that we're doing for our tutorial. I need to get this done today. So I need to be a bit quick. But no pressure. No pressure at all. So, and the reason I'm recording this instead of streaming is because I'm a bit worried about internet speed. Anyway, without any of that, we have our scene. It runs, but see, I'm trying to click, and I'm trying to type with my keyboard, and it's just not working. There's nothing happening here. So this is what we've programmed here. Firstly, we've got variables for our look speeds. We have our horizontal look speed and our vertical look speed because those are handled differently. Before we get into what's in our ready, we need to look at how we are actually looking around in the world. We do that with the function unhandled input. I'm repeating what I did from the tutorial. The unhandled input, if I can go to the documentation, it's called when an input event hasn't been consumed by the input function or GUI control item. Not entirely sure what that means, but this is where we're doing our looking. This is where we're handling our looking. And we're passing in an event variable. And if that event variable is input event mouse motion, and the input event, an event is just when any kind of thing happens from the player, when the engine detects an input from the player, kind of. And the input we're detecting here is the mouse motion. So when we're moving the mouse. You know, like when you move a mouse and it can detect with the little red laser at the bottom. I mean, there's no red laser on here, but point still stands. Three things are happening in this if statement. We have our rotation along our y-axis. Now, let me actually go into what we're doing here, the 3 bits. Well, the 2 bits, the third one is more of a rule against something anyway. We have our character. Now, we want to be able to look horizontally as well as vertically. And that together, we can look anywhere in the world. When we're looking horizontally, we basically want to move our character along the y-axis. So you can see here the green is the y, and we're in our rotation mode. We're going to rotate along that axis. Where's our transform? Our transform's here. Yeah, you can see we got that there. So we do that by taking the rotation degrees dot y, which is connected to our character body, which is connected to our player. So we're taking the whole player with this. We're taking the rotation degrees around the y-axis, and we are changing it with the event, which is our mouse motion, dot relative dot x, which is effectively just detecting the difference between where our mouse was and where our mouse is between frames. And the dot x just means that we're checking the horizontal dimensions of our mouse movement. So it's checking when our mouse is going from left to right. It's not checking if it's going up to down. And we multiply that by our horizontal look speed, which, can be changed from the top here if we want to change the speed. And if we run that, you can see that it's working, that we're looking left to right. That was a bit odd. Let me just... Okay, yeah. It's fine. And we do the same thing, kind of the same thing for the vertical looking, except we are changing the camera instead of the player, because while with the player, we are, we are, we're just moving our whole character around the y-axis. If we were to do the same thing, looking up and down, and with how our character is oriented, looking up and down would be around the x-axis, the red line here. If we were to do the same thing we were doing for looking left to right, you can see that the whole player character is just tipping back and forth. For this game, we don't want that to happen. What we instead want to happen is the head or the camera to look up and down. Because if you think like, yeah, let me just change here. When we are, why is my camera like this? Make it a bit higher. Sorry, I was just changing that. Yeah, when we're looking left to right, we obviously move our head if we want. But we can also move our body to look around, to look left and right. Looking up and down, we move our head up and down, but we don't really move our body like that. Also, it's just, I don't know, um, with how we've set it up in the project, it would just be not correct to do it this way. So we're instead going to change the vertical of this. And you can see in the little camera view off on the side here that it is changing that the way we want it to. And having the gun as a child of the camera makes it so that it's like we're holding the gun. We're going like, woo. So, position is fine, rotation is fine. I'm just checking everything's set to default. It is. Yeah. So what we're doing is we're catching a reference to the camera 3D, which we do by not on this one, but we would do access to the unique name on the camera. And that means we can access the camera with this keyword here, %camera 3D. And then we just do the same thing we did for the horizontal movement, but inverted. So we're rotating around the x-axis of the camera in relation to the y movement of our mouse. And then we're multiplying that by the vertical look speed. So we save that. You can see that I'm looking up and down, left and right. Now, this third part fixes an issue that we can see here. So you can see if I look up, I can look down. But if I look down, and I keep looking down, and I keep looking down, and I keep looking down, we've turned ourselves upside down. We don't want that to happen. The same thing would happen if we kept looking up and up and up and up. We would just come back around. So we use a clamp function on the camera's rotation. And we make the rotation of the camera equal to, obviously, itself, but then we clamp it to a minimum value and a maximum value. With that implemented, you can see, pay attention to the mouse or the cursor. As we're going down, you can see that we're not actually looking down anymore, even though the mouse keeps going down. And the same thing goes up. It's a little harder to see because there's no clouds, but pay attention to the lighting and shadows on the gun. And notice how it's kind of stopped. There might be a little bit of difference because we're still detecting horizontal movement and that's affecting the shading. But that is working and it's clamping it within, like, obviously vertical bounds. Whereas with the horizontal stuff, we don't need to do that because we want to be able to turn our little guy around and around and around. Now, that works, but you can also see the cursor. We don't want that to be happening. And also, if the cursor exits the game view, we just stop turning. We don't want to be able to just be in the game view without, exiting out of this. But we also don't want to get stuck in the game. We want an option to get the cursor back. So we do two things. First, we call a ready function, which is called when the game starts. We set the mouse mode, the input.mouse mode, to mouse mode captured, which basically makes the cursor disappear and become captured within the game. So it's not leaving the game ever, but it's still functional to be able to do the relative input events. But should we want to get our cursor back, we need to implement a way to get it back. And we're doing that with an event.isActionPressed. And this function refers to the input map that is built into Godot. So if you look at project settings, we're at the input map. We have actions inputted here. We have the one that we're using for the mouse to get the mouse back is the UI cancel. And this is just a built-in action. You can make your own, or you could choose to use these, choose not to use these. The UI cancel reference, which we're calling here, is checking for the escape key when we press it, when we press the escape key. So what this is saying is, obviously it's checking, how we're going to be moving and looking around in the world, but it's also checking if we press the escape key, then it will set the mouse mode to visible as opposed to captured. So if we play that, you can see that the mouse just disappeared because it's in the game now, because that was called when we did the ready function. Just cleaning my glasses. So you can see I can keep looking around and keep looking around, like it's just as far as my mouse pad will will take me. And we can keep looking up, we can look down, but we're still within those bounds. And if I want the cursor back to close this, get back to my code, just hit the escape key. You can see it's there. We just exit out, and there we go. Now that's the looking around done. What we also did was we did a physics process to check, or to program the WASD movement of our character. So instead of looking around, we're actually moving our character forward, backward, left, and right. So we need to declare a speed variable for moving. Now we can do it as a constant within the function, or we can do it as a global variable throughout the script, like we've done up here with the look speed. But the tutorial that I was following did it as a const in the function, so we're just going to go with that. Firstly, what we did was we made a variable to capture the planar movement. So we haven't programmed jumping yet. We're just programming movement along the ZX or the XZ plane. Along like this, using the x-axis and the z-axis. And we capture that by creating a vector2, putting it into input direction 2D, which we've called it. That's our variable. And we've done the same thing we've done with the event.isAction pressed up here to capture that that value. I can clear that. You can see in here we have, these are not built-in actions or inputs. These are ones that I made. Yeah, these are ones that I made. We have a jump and we have a shoot, but we're not using those just yet. Those are going to be later. I've done a move left, move right, move forward, move backward. And we're obviously calling those header names in the quotes there. And the actual button that we pressed exists within that. So when you create it, obviously you can see here, it's listening for input. You just tap the key that you want to be the set input for that input action. You can also find it. You can scroll through and see all the available ones that Godot does, or you can do filter by event, listening for input, and I can say like tap A for left, and I just click OK to add it there, but I've already done that, so I'm going to click cancel and then close. And now that is all in there. And you can see there as I've hovered over it, the input.getVector is a vector2 specifically for input. And you can see there it's checking negative x, negative y, positive y. And you only need the x and the y for 2D. We're going to adapt that into 3D in a moment. But the negative x is the move left, positive x is the move right, negative y is the move forward, and positive y is move backward, I guess. Directions are confusing. So we've put our input into our 2D. Then we want to put our 2D-dimensional, our two-dimensional, our two-dimensional input into a 3D vector because we're moving in a 3D world. We put it into vector 3. And the vector 3 takes three local variables, an x variable, a y variable, and a z variable. Now we've put the input direction 2D x in the x place. We've not done anything for the y because the y is vertical. And we're only moving along the x and the z's. We're not moving vertically. We're only moving horizontally, so we put that as 0. And in the z field, we've put the 2D.y. But we're not doing y movement, we're doing z movement. We're just taking the y from the 2D and treating it as the z of the 3D. I promise, it makes sense. I understand it. Explaining it is a different thing. Right, we're not going to do that just yet. Instead, we set the velocities of our player. We set it equal to, not the direction, we'll do that in a moment, but if I show you what I did before, what the tutorial did before, we set the inputs, if we set the velocities equal to the inputs here times our speed, and then we call the move and slide function to use that. The move and slide function is one within the physics process. We do that. We play. So you can see. Now, I've pressed S, but I've moved forward. If I press W, I'm moving backwards. If I press left, or if I press A, I'm moving right. If I press D, I'm moving left. That's backwards. I'm not too sure why it's backwards. It's probably some, like, something to do with the data passing through the vectors. I can't map that out exactly. But I do know, based on the tutorial, that if we introduce, oh, this is what it was. So you can see, like, even though they're reversed, moving forwards and moving backwards. But if I face this direction, if I press the keys for forwards and backwards, I'm actually moving sideways because the transform has been locked to a specific orientation. And that is like this. Doesn't matter where I'm looking, the transform is statically bound. So what we do is we create a direction variable, which is equal to the transform basis times the input vectors that we've established prior. And then the velocity, we just pass in the transform basis we do the transform basis into the velocity x with the move and slide. We implement all of that. So I move forward, move backward. Now it's been fixed. Like A makes me do left, D makes me do right, W forward, S backwards. Then if I look here, that's forward and backwards. That's left and right, as it should be. And that's the movement programmed. That's where I left off in the tutorial. It's been a good 24 minutes. Nearly 23, 24, coming up on 24 minutes. That's what I've done so far. And it's time to get on with the rest of the tutorial. I just mute myself quickly. All right, so I've got this video. I got some tutorial left to do. I have to finish the rest of this by today, I think. How have I scheduled myself? I have specialist today, which is this. Specialist tomorrow as well. Okay. So I have today and tomorrow to finish the tutorial. And the next week is going to be my own original version of this. So, yes, I want to finish the tutorial today. So I'm gonna take a quick break. Gonna start a new recording. I'll stitch this together as, you know, the devlog for today. Okay. I realize I'm doing this a lot when I start recording. So Next up, I'm going to be doing the rest of the tutorial. That sounds like a big statement, because it kind of is. Because I do need to get through the rest of the tutorial today. I could probably stretch it a bit into tomorrow, but tomorrow I need to have my reflection done for this. I also need to remember to iterate upon the tutorial and show evidence of it. Evidence is going to be these videos. And if, they don't accept videos, I can probably put together screenshots. Now if I show you, I've got my Trello here. We are on game mechanics and player systems, player movement and controls. And I need to produce a working gameplay prototype that focuses on those mechanics. Now the tutorial isn't going to teach me how to do these things. I mean, they're going to show me kind of the basic things, but this tutorial I'm following isn't going to tick all those boxes, so I need to do a lot of independence next week, which is going to be a good opportunity because being able to demonstrate that I can apply these things on my own. It's good points, good brownie points. So yes, I need to prototype with reflection, evidence of iteration, which I'm kind of doing here, and then my original work is going to be next week. Today, we're going to get the prototype done and the iteration done. Explanation of a technical decision as well, probably? Probably. For now, let's just focus on this. Yeah, let's get to it.
The combination of a direction and a speed. It's a 3 vector, like our direction vector.
I've already done this. I've already done that. Hello, minions. Realize I can, using the mini player function that's on KDE, I can just skip through tutorials.
The screen.
That's a fun little hack. Coding the jump and the fall. Okay.
Now we're going to implement the...
What are we doing again? Make the character go up when pressing jump. Apply gravity to fall back on the floor. Only allow jumping when the character touches the floor. Jump higher when keeping the jump key down. And add an aim reticle at the center. Okay.
At the center of the screen. Now we're going to implement the jump. The player can totally cross the platforms here because the gap is not very big and the capsule of the player is pretty big, but we're going to add a jump to simulate crossing this gap, and in case you want to do a level layout where you have these floating platforms and the player needs to jump in your final copy of the project. So we need to add code for jumping before the call to move and slide. Because this function call takes care of moving the character, we need to set the jump and fall velocity beforehand. And for that, we'll be working on the velocity.y. To implement the jump, we need to first detect when the player is pressing the jump button. And for that, we're again going to define an input action to use in our code. So let's head to Project Settings, the input map, and add a new action named...
I will just clarify. This is a video tutorial. Everything else is my own stuff.
Jump. So you type the name in the add action bar.
I've already done that.
To define it, and then click the plus button at the right.
Click the plus button.
And press the key you want to assign to the jump action. In my case, it's the space bar. So
I've already done that.
And then you can close. And in the code, before the call to move and slide, we're going to add our condition for the jump. So this time we're going to add the input check directly in physics.
And that's right, we're doing it in the physics process because we're handling the physics of our character body 3D. We didn't do it for the movement because there's no, I mean, there's a little bit of physics, but it's not a physics process. It's just changing the transform values, specifically the rotation values, physics process when we're jumping, because we also need to have the gravity affect us as well.
Physics process so that it's grouped with our movement code, as jump is movement code as well. And we can use the input singleton again and access its is action just pressed function with the dot.
That's what I want to do.
The action we want to check is
just
jump.
Pressed. Just pressed.
When this happens, we're going to
just pressed. Just pressed. Velocity dot y.
Change the y velocity of the character, the vertical velocity, and set it to a positive value, which will make the character go up. So you can test, press space, and the character keeps going up.
Okay, yeah, that makes sense. If we do the jump thing, which I've assigned to space, velocity y equals 10. Now it looks like that's going to be static and unchanging. So if I press space, then it is just going to put us up because our y velocity is set to a positive 10. We need that to not happen. I think. What do I think? I don't know.
There is nothing pulling it down.
We need gravity.
You might be wondering why we do it like this, and earlier we used the unhandled input function. Well, you have these two ways of handling inputs in Godot. You can use the input singleton and make the checks directly where you write the rest of your movement code or update code, like this. And this is good for grouping the code in one place and making the logic easy to read. Earlier, we were checking for mouse motion, and the unhandled input function is a bit more powerful, and it allows us to check for the mouse motion a bit more easily, a bit more efficiently. So that's why we put this mouse motion logic there. I would also say that the code that does input checks relative to UI or general things like toggling the mouse, toggling the game full screen, things like these, it's common to put them in unhandled input and out of the way of the update function because they are pretty rare events that you don't want them in your gameplay logic. Okay, so the character jumps, but it doesn't fall, so we really need to add that next. And
we need to add gravity.
We can just apply some gravity, some downward acceleration every frame. So above the line that checks for the jump input, we're going to subtract from velocity.y some value. So I'm going to subtract 20 times delta. Okay, so gravity is an acceleration. It's a value in meters per second squared. And a velocity is a speed in a given direction.
Why has that happened? Delta not declared in the current scope. It's because I've done that. I've put my underscore there. The reason I put an underscore there is because I don't know if they get the error in the tutorial, but I get the error if I don't use delta. It depends whether I'm using it or not. So let me just get that out of the way. If I don't use delta, but I have declared delta in there, which you need to do, I think, you get a warning saying that delta's never used. Now, that's not going to stop your game from running, but that kind of, I don't know, I don't like having the warning there. And I want to fix it if possible, so one way to fix it if you're not using delta in your program is to do an underscore beforehand. This is a feature of Godot. I don't know if it's in other engines, but I know that it's in, I know that it happens That's how it works in Godot. That's how it works in Godot. And that gets rid, you can see, of the warning. But obviously, now that we're using delta, I need to change that to a regular delta. Scope now it is declared in the scope. It seems like. Oopsie, my bad. What am I doing? I'm getting my tutorial back.
In meters per second. To make the two compatible, you need to apply an acceleration. To apply the gravity, you need to multiply it by a time value. This
Delta
makes the units compatible. So in that case, we use delta. And delta is typically the time elapsed between the previous frame. In the case of physics processing functions like these, delta will be a fixed value to ensure that the physics simulation in your game is stable, even if the game slows down or accelerates. So this is used for stability.
Delta is also used to standardize the passing of time, or delta time at least, is used to standardize that across different frame rates. Because a lot of game engines base the animation and the timing of certain events based on the frame rate that the players are playing on. So, and obviously people play at different frame rates. Some people play at 60 hertz. Some people play at 60 hertz or 60 FPS. No, yeah, hertz. It's hertz that are affected. Some people play at 60 hertz. Some people play at 120. Some people play at 180. Some 240. Honestly, 60 hertz is just fine, but I'm getting into personal preferences.
One more thing you might be asking is, okay, why do we multiply this value, the gravity, by delta, but then the velocity would just assign it like this, and we never need to multiply it by delta? If you've used other game engines, often you have to apply the velocity.
Because physics process is a process. It's like the update function in Unity. This whole thing is being called every frame. And we have this being called every frame. But we don't want it to be called every frame. We want it to be called at a fixed rate, regardless of frame rate. So we do delta on that, but we don't do it on this because this only happens if we press the jump key.
To yourself and multiply it by delta to move things. Well, in Godot, the character body 3D does it for you. Other nodes might require multiplying by delta, but not this one. Now you can run.
Oh? That... Okay, well that's just confused me a bit more. But we'll see if this works now. Yes. Wait, I'm moving around. I can look and move. That works surprisingly well. I was expecting something to go wrong. Because it's... Because the velocity.y is being minus equaled 20 constantly. Which is... That doesn't seem right. Process physics interpolation. Where can I check? Can I check the velocity? Character body 3D I think it'd be in. Collision input. Would it be under collision? No, it wouldn't be. We're doing it to the physics body. Angular linear. I'm gonna be honest, that's confused me a little bit. Oops. I wonder if minus equals just means that it's setting it to 20.
The game and press space for the character to jump and fall. We have a problem though. What happens if I press space multiple times? Press,
Oh, I didn't even
and
think about
yes, the
that.
character keeps jumping. Why is that? Well, we're only checking.
Time to eat your fuel, Michael. Fuel, Michael. More fuel.
Oh! Flippin' ads. Okay, I think I understand it now that I've thought about it. Let me get rid of that and say, so I was confused because we're doing minus equals 20 every frame. How come I walk off this? I don't just go shut off the ground, because I'm thinking if it's setting it to minus equals 20 every frame, it would just, like, every frame eventually add up to like a bajillion, like negative bajillion velocity y. But I think it's just because we are on a platform, because we are colliding with something that is stopping our velocity, it's just setting it to 0 even though we're setting it to 20. So it's in a constant battle of like 20, 20, 20, 0, 20, 0, 20, 0. So if and it's setting it to 10, and equals 10. What happens if I minus equal that? I'm playing around. Yes, okay, so it's just making us go further and further down. And making us go faster. Okay. Obviously plus equals, it's just the same as doing 10. Plus equals and equals. Now, if we get rid of this, because we did this because we just went up constantly, if I still have it set to plus equals 10, then I'm just going faster each time I press space. But if I just do an equals, then it's not adding 10 each time. It's just constant. So I'm spamming space right now. So we do an equals 10 just to set it. Plus equals to add it. Now because our velocity is, I assume it's being set to 0, you know what? Print. Do a print. Do a debug print. Okay. Print velocity dot y. I need to hang on. This is annoying me. I don't want to make it a floating screen. There we go, you can see. Okay. So plus equals is being set to that. And you can see it's printing our velocity y. It's being 60, 60, 60, 60, 60. If I just set it to do 10, and it's just setting it to 10 each time. Now, if we do this minus equals thing, I also need to do an if velocity dot y is equal to 0. Print vy. I need to do string, hang on. Vy is 0. Now this will test my theory that if it's set to 0, no, it's setting it to 20. CO2 minus 20 is minus 20. And we've reached not terminal velocity. Let me just do a, this is going to be terrible. We're going to do a print. We're going to do a print velocity y every frame. You can see it's changing positively when we press up. I'm looking at the terminal, or the output. I see, so we press that, it goes up to positive, but when we fall, it goes into the negatives, but when we hit the platform, it's effectively setting it to 0. There's some decimal stuff happening, but it's setting, so my theory was right, because we are hitting the platform, because it's stopping us, our velocity has stopped. Great. Oh, I love this. There's a lot of things. Great, okay. So then we do that. And it's cool. So that's where we are in the tutorial. Let's bring this back. That's such a cheat. Oh. What have I done? Oh, I gotta actually skip it.
For the jump input being pressed, and if so, we set the velocity.y to 10. We really need another condition there, and the other condition for a jump is that the character has to start from the floor. So after checking...
Now, yes, it's checking grounded condition. Now, in Unity, I think I did this by checking, like doing a collision check function at the end of everything. How is he going to do it?
For the jump input, we're going to use the AND keyword to combine it with another condition, and that condition is going to be a call to the isOnFloor function. This is a function, again, provided by the character body 3D. Again, you can control-click it to access the documentation.
No, I was thinking I needed some way to tell if we're colliding on the floor. Or we're just... And I guess...
And this is a function that will return true if the character collided with the floor on the last call to move.
To move and slide. Return true if the body collided with the floor on the last call to move and slide. Otherwise turn false. How does it know what the floor is? How does it know what the floor is? Is on if the this is confusing. Bool is on floor. That doesn't tell me anything. Oh, it says right there. I'm such. Ugh. I need to read. You learn how to read. The up direction and floor max angle used to determine whether a surface is ceiling or not. If floor is not. Up direction. And floor max angle. Maximum angle where slope is still considered floor. The default value equals 45 degrees. Okay. I understand it a little bit more. Be nice to see that a bit more in depth, but we got a tutorial to go through.
And slide. So now you have that, you can run and try to press space multiple times, and you can only...
Right, I will come back to this in a moment. Okay, hi, I'm back. I was just having dinner. Right. Let's continue with the tutorial.
If the character is...
I understand how this gravity situation works now.
Is already on the floor. There's one more mechanic I want to show you for the jump. It's the ability to jump for long...
Let me just organize my stuff. I don't know what those are. I will check them later. Oh, wait, no, yeah, one of them is the video that I'm doing now. Duh. Okay. At 17:44, it's 45 now. Yeah. That's what we're doing. Great. Cool. We've got it.
Or for less time, based on the amount of time you press the spacebar. So we're going to add that next.
What are we adding next? God darn adverts.
After the jump input code, we need to add a new condition, a new branch, and we're going to check if the jump key was released while the character is going up. If that is the case, we're going to the space bar. So we're going to add only jump if the character is already on the floor.
Okay. Jump higher when keeping the jump key down. Cool. So let me just check that that this is working. So yeah, we can look, we can jump, and we, even though I'm spamming space, I'm only jumping once. Sweet. Jump higher when keeping the jump key down.
There's one more mechanic I want to show you for the jump. It's the ability to jump for longer or for less time based on the amount of time you press the spacebar. So we're going to add that next.
That'll be good.
After the jump input code, we need to add a new condition, a new branch, and we're going to check if the jump key was released while the character is going up. If that is the case, we're going to reset the vertical velocity. So we can write elif. So we're going to either run this branch, or if the player is not jumping this frame, We're going to check for the other. We're going to check for input.is action just released, jump, and the velocity of the character on the vertical axis is greater than 0, meaning the character is currently going up. This is a good pretext to show you that in the input singleton, you can check if a button not only was just pressed, but also when the button is released. Right? And in that case, in the condition, we want to reset the vertical velocity. So velocity.y is equal to 0. If you run the game now, you can keep the space key pressed as long as you want, or the character.
Right, I forgot what he said. What did he say? What is this code telling us? When we press jump and we're on the floor, set to that. Else, if it's released and we're still going up, set the velocity to 0. Okay, so this is our maximum jump. This is basically cutting our jump short. So if I save that and I play that, I'm only tapping the key. But if I hold the jump key, now that's a bit sharp. I need a bit of smoothing on that.
You can keep the space key pressed as long as you want, or the character to jump to the full height, but if you release the key before the player reach the peak of the jump, it's going to fall back down.
Randomly, I'm going to put this into a gravity variable. Constant gravity equals that equals no. Yes. Gravity. Jumping. Jumping. And we have walking. Constant. Wait, assigned. Oh god. Assigned value for constant gravity isn't constant expression. So that can be a variable gravity. That makes sense. Because it depends on delta and it could change. Right.
This is a nice thing for game feel. It's very common in platformers and FPS games. So there, you know how to do it now. Before we move on to creating our...
Now I've just reorganized it. If we want it to be smoother, I want it to be smoother. That's what I want. I want to smooth it out. So it needs to gradually it needs to gradually decrease. I feel like I need a for loop for that. But I don't know how to do for loops yet. So I'm just gonna put a note here and say, jump cutting feels too sharp. Want to smooth it.
Own game level, let's add a reticle at the center of the screen that the player will use for aiming. You can mix and match 2D and 3D nodes in Godot and combine them, and it kind of just works, so that's what this will show us. In the file system doc, at the bottom left of the screen, locate the reticle.png image. It's in the player directory. Then I'm going to go to the 2D screen doc. At the bottom left of the screen, locate the reticle.png image. It's in the player directory. Then I'm going to go to the 2D screen by clicking 2D at the top of the screen.
2D screen.
And click and drag the reticle.png image onto the viewport. You want to press the Alt key before you release the mouse click. That way, Godot will ask you what kind of node you want to create. So by default, it will... You want to press the Alt key before you release the mouse click. That way, Godot will ask you what kind of node you want to create. So by default, it will select Sprite 2D, and we want to create a texture rect. A Sprite 2D is a texture image with a position, rotation, scale, and so on, and so is the texture rect, but the difference is node you want to create.
What is it doing?
Onto the viewport. You want to press the Alt key before you release the mouse click. That way, Godot will ask you what kind of node you want to create. So by default, it will select Sprite 2D, and we want to create a texture rect. A Sprite 2D is a texture image with a position, rotation, scale, and so on.
Okay.
And so is the texture rect, but the difference is it's much easier to keep a texture rect, one of these green nodes here, centered on the screen at all times. So that's why we will use it here.
Okay.
So let's click OK.
Okay.
To add the reticle. And you'll see when you select the reticle node, which is a texture rect, that it has some green pins when you select it with the select mode active. These pins tell the engine at which point to anchor the texture. So when the game window resizes, the node will preserve the margin relative to the pins. Currently, it's anchored at the top left of the game window, and we want to change that to always be centered in the game window. For that, with the node selected, in the toolbar at the top, you want to click this icon for the anchor presets. I'm not sure how to describe it, but click it and you're going to see a list of icons to anchor the node in different places. You want to select the center one, and this will force the node at the center of the screen. So depending on where you drop the texture, selecting this center preset will have moved the texture to the center of the screen.
Beautiful.
Now, depending on your screen resolution, the reticle might be way too big on the screen. I have a pretty big display for recording, but you might want to scale this down. To do that, select the reticle node, and in the inspector dock on the right, you want to change the expand mode, and I guess, well, we're just going to change the expand mode. So change it from keep size, which forces the node to preserve its minimum size, to ignore size. And then you can press Shift, Alt, click and drag on the corner handles to resize the node down interactively. Another thing that's useful at this stage is controlling the game resolution and the game stretching mode. To do that, we can go to Project Settings, and we go back to the General tab. This tab contains all sorts of project settings, as the name suggests, and options you can use to change how the engine behaves. And in the
I think I manually set mine to 720 and 1280.
Display,
because that scales neatly from 1080p, which I believe my monitor is. Yeah, my monitor is 1080, 1920.
Section
1920,
left,
1080.
you will see the window subsection in which you can control the base resolution of the game and its scaling mode. So it's a good time to change the viewport width and height. This is the resolution of reference for the game, and to make it simple, a very common one is 1920 by 1080. Changing this affects the rectangle used as a reference for 2D graphics. You can see that now our reticle is not centered anymore, so we have to go back to the scene, select the reticle, and recenter it.
There we go. I already did that because I already had it set.
Going back to the project settings, this size here is mostly used as a reference, but it's also going to be the base definition at which the 3D graphics of your game are going to be rendered. We can check that by going down to the stretch category and changing the mode from disabled to viewport. The viewport mode is going to use the viewport width and height and stretch the image to fit your screen. So even if the screen is very large, it's going to render at this resolution. And this is really good for 3D games as a default because most of the performance cost of 3D games is the resolution. So if you don't use this option for people with a 4K screen but maybe not super powerful graphics card, your game might be too heavy at launch and be sluggish, and they'll have to go to the options to change the resolution and whatnot, while a smaller resolution might give a better base experience.
Okay, I think I can run this at 1080p. If I just run my game quickly. I fell. So that's doing it. There's a bit of weird aliasing going on, I think. It's probably just the scaling. I think I'm gonna set it. I'll just keep it at 1080p because he hasn't set it that.
With that, you can press F5, run the game to see the result. And I don't know if you can notice it on the video because we downscale it for YouTube, but my game is rendering at a smaller resolution now.
Creating the level. I've created the level.
You find candidates who are 30% more likely to stay for at least a year.
Amazing. Windows 11 sucks. I hate Windows 11. Linux is the way to go.
In this part, you will create the environment.
Oh, we haven't actually made the level yet. I'm in my bed.
We'll first create a platform for the player to walk on, add a sunlight and a blue sky, improve color balance and contrast using the environment, add fog to give depth to the scene, design a material to control the platform's color and texture, and duplicate platforms to assemble the level.
All right, so we've been doing everything in a... Pardon me. We've been doing We've been doing everything in a temporary level. Sounds like we're going to be making our own level. So...
Now that we have the player movement...
Also, I should note, I think it's so cool that the 2D view, the 2D and the 3D are both rendered during the game. I think that's really cool.
In place, it's time to learn to make the level as promised. We will look at how to create the material, change the colors, create the environment, the lighting, the fog, and you will be able to make the little level yours. So let's get started.
Right. Cool. We've got an hour left of this. We're doing really good. Before we go, I'm going to save. I'm going to commit this. So, because I'm on analytics, I have to do it this way. think that has worked. Programmed looking and movement. Of a 3D player character. That was 20 minutes ago. Oh, wait. Push some references. Oh. Okay, right. I'm fine. It's fine. It was working. Again, I need to learn how to read. It was working. If I do a git pull, says I'm already up to date. Great. Okay. Emails I can set. My email address is to be private. Okay, so then, right, let's try this again. Right, had a bit of a git malfunction, kind of, sort of, but if I, for example, if I go in here, let's change the size of the reticle, for example. Let's just run to see how it looks. I don't like that, but we'll keep it as is. I've saved it. Changed size of reticle. One file changed. Yep. Then we do a git push. Realviz. See. There we go. Right. Then, if I go back to face, I go to that repository. And now it says I changed the size of the reticle. If I look at that commit, what is it? What details are in the commit? That might expose my thing. That's fine. That's okay. Oh, okay. It's fine. It was fine. I just saw red and panicked. So that's okay. Oh, I got it. Yes. I've got it. Right. Right. So let's make that a little smaller. Let's run the game. And I like the size of that. Is there a way to access terminal from in here? Here, let me change here. Sorry. Yes, I am. Cool. I'm just changing the size of the reticle again. I want to see if I can access the terminal from within here. It doesn't look like I can, but that's okay. I can do a git commit am and then a git push. Then I can paste it. Brilliant. Okay.
Let's first add the platform and we will then...
Right. I need to remember. What was I doing?
Let's get started. Let's first add the platform and we will then add the lighting material and design the level. We're going to create a new scene for our level. So go to Scene, New Scene, and click 3D Scene. Rename the root node to Game and go to Scene, Save Scene, and save the scene at the root of your project. I'm going to fold
at the root
and save the scene at the root of your project.
I think that's just because how he's organizing his. I have mine organized into scenes, and I have a scenes folder. I have my Git folder, which has my token key. That's scary to keep in there. I may not actually keep that in there. I might move that to my top level for projects. Yeah, we'll do that.
I'm going to fold the player folder and let's get to work. So for the platform, we're going to use a CSG Box 3D node. So click the Add Child Node button at the top left of the scene dock. You can press Ctrl A, Command A on your keyboard.
Ctrl A.
And search for CSG Box 3D. Press Enter to add it, and this creates a box with 6 handles that you can click and drag to resize the box in the corresponding direction. CSG is short for Constructive Solid Geometry, and it's a technique used by different engines like Unreal, the Source Engine, or Godot to prototype game levels. You can then export that geometry and have artists design final assets in programs like Blender. It's useful because it lets us quickly prototype the level, and we can add collision shapes very easily to platforms and geometry we create with this. So let's resize the platform, and for that we're first going to turn on snapping.
I was just going to say snapping.
So click the snap button. You can press.
I was just going to say, because I was doing it very finely, but I wanted the snapping ability.
Press Y on your key.
I love Godot. Can I just say I love Godot so much. They recently updated their UI in their 4.6, and I had a look around, and it's laid out exactly the same as I'm on version 4.4. I kind of prefer the boxiness of 4.4. I'm not really messing with the smoothness of the new one anyway.
Or to toggle it, and once you've done that, moving or doing resize operations on the box will snap to 1 meter increments. So if I click and drag on one of the resize handles, it will snap to the grid. Let's resize the box by clicking and dragging on the sides, and little tip, you can press Alt on your keyboard while doing so to resize symmetrically. Notice how when I resize the box, in the inspector at the top right, this changes the size property of the box. So I'm gonna drag it vertically, and there's a slight delay, but when you move or interact with something in the editor, very often you're just editing properties of the node that update in the inspector.
Okay. Yeah.
So you can also change the property in the inspector to see the change reflected in the view.
I don't know why I would do that.
For example, if I select the Y channel of the size and set it to 10 meters, the box becomes taller. Okay, so I have a starting point for my platform. I want to move it down so that the top face aligns with the game grid. This will make it easier to then place other assets on top. And it can be difficult with snapping to do that. So when you have this kind of problem where you can't perfectly align the thing, press the Shift key down to snap to smaller increments. In this case, to 0.1 meter increments. And this allows us to perfectly align the platform with the game grid.
Looks perfectly aligned.
Okay, so we are now ready to add our player to the scene. So for that, in the
what does he have his
ready to
dimensions set to? He has it set to 6x5. I have mine set to 5x5. I will probably set mine to just 6x6.
Player to the scene. So for that, in the file system dock at the bottom left, expand the player folder and click and drag player.tscn onto the platform.
For me, instead, that's going to be my scenes because that's where I've put it. He is a little big for the platform.
This will create an instance of the player scene, which is a reproduction. Scenes work like templates that you can nest into one another. They're like blueprints, prefabs in Unity. This is how they might be called. And you can nest them into one another to compose your game. An important note, when you do that, when you drag and drop a scene onto the viewport, Godot adds the scene instances and the nodes as siblings. This means that if I move the platform, it will move independently from the player. You could also add the player as a child of the platform so that it moves with it. Nodes move with their parents by default. I'm going to click and drag the player onto the game node to make it a sibling of the CSG box again.
I'm realizing that our player guy's a little backwards. That's fine.
And this is important because when you build your level, often you don't want the player to be attached to a single platform, so you can easily move it to different locations for testing, for changing the start position, and so on.
Oh! I think I've just realized. The reason, if you remember before we did, sorry, off topic. If we look at our player script here, before we did the direction to change the transform, it was making it, the controls were inverted because our player was facing the wrong way. We made him that way. But in theory, if I rotate him like that, and then we play our game, it still works. Okay. I'm understanding.
Okay, the player is a bit small compared to the platform, so I'm gonna make sure that I have select mode active in the toolbar at the top, and then you can click on the CSG box geometry to select it. Then we want to change its size, so I'm going to do that in the inspector this time. I click the field for the x-axis and type 10.
I also need to set game as the main scene so that when we play our game, it goes in there. Obviously it's not working because we still have a shit ton to do.
Then I'm going to press tab to move to the Z field and set it to 10 as well and press enter to confirm. So that's how you can quickly change properties in the inspector using tab or keyboard navigation. Now we can run the scene, and what do you think will happen? I'm going to press F6 and the character falls. So in games, there's a difference between the visual and the physics layers of the game. Currently we have a box that's visual and the gun that's attached to the player that are visual things, but they don't have collision information, unlike the player that has a capsule shape. So we need to turn on collision information for the platform for the player to not fall through it. With the CSG box node selected, click the checkbox next to use collision. And now you can run the scene again by clicking this button at the top right or pressing F6 on Windows and Linux, and the player will stick to the platform and you can move over it. So that's a step forward.
Are weird.
Now, when running the scene, you can see that it's all gray, and this is because we don't have any lights in the scene. It's different in the editor because by default, Godot gives you a preview sunlight and environment. You can click the sun icon and the globe icons in the toolbar above the viewport to get a faithful idea of what the scene will look like when running it. So we need to add some lights and an environment to change the gray background now. Oh, by the way, the box is blue right now because it's selected in the editor, but by unselected, you can see it's gray as in the running game. So, as a child of our game node,
I'm gonna quickly check what this was posted 9 months ago. Okay. Huh. 'Cause my game looks different to his.
Let's add a new directional light 3D. You can press Ctrl A, Command A to bring up this window anytime, and press Enter when you've selected the directional light 3D node. And this adds a directional light, as the name suggests. It's like a sunlight that gives a uniform directional light to the scene. I'm going to move it up a bit and rotate it to angle it. And you can see a white arrow in the scene that represents where the light is coming from.
Cool.
So you can angle it down to give some light to the top face of the platform. Okay, that's fine, but the scene is still pretty gray. So let's add an environment to change the background and some of the lighting of the scene.
We want a skybox.
Add a new world environment node to the scene as a child of the game node. And this is a node you can use to give a specific level or scene a specific environment. An environment encompasses many things like what is drawn in the background, what kind of ambient light is applied to the scene. So currently the shaded areas are gray, but you can change that with a world environment. You can change some visual effects that are built into Godot, like fog and so on. By default, the node doesn't do anything because you need to add an environment to it in the inspector. So click the empty slot next to environment and add a new environment resource as a child of it. Then click the newly created resource to reveal all its properties. I'm going to make the inspector a bit larger, and you can see there's quite a lot. So the first section, background, is for the background. You have the ambient light to change how shaded areas behave. And then you have a bunch of post-processing effects built into the engine that we will not all get into. We'll focus on the tone map and the fog here, which are two of the most common ones.
This Valentine's Day, love will find a way.
I believe these are yours.
To click. Keep it fresh.
Let's start with the background. So click the background category to expand it, and you can see that the mode is set to clear color. Game engines, every frame usually...
No, I don't want to delete world environment. I want to close the file.
Clear the game window or the screen and draw what's called the clear color. It's the gray you can see in the background. That's the default clear color in Godot. And then the engine draws on top of that color to paint the screen.
Okay.
We can change that clear color for the entire project, but with the world environment, we can better control the background per game level. That's what we'll do here. So click the drop down to change the option to custom color.
Custom.
This will bring up a color picker that you can click, and then you have a circle and a slider you can use to pick the color. So I'm gonna click the slider on the right and pull it up to make the tone a bit lighter and reveal the color wheel. and then click and drag to go select a nice color. So for this project, I want a pretty bright blue, and I'm gonna go with something like this. Just pick a color that you like, or basically the sky, and you will notice that it also affects the shaded areas in the game, so it makes the shaded face of the platform a bit blue. This is because by default, the background applies what's called ambient light.
That is an awful
You can
color,
see that if you expand
we'll go with
the
it.
ambient light category, the source is the background, and so this color from the background gets added a bit to the shaded areas, giving them a bit of a tint and making them a bit lighter. We can add a bit of warmth to the shadows by changing the ambient light source. So click the drop-down menu next to source and select color, and then you can click the color picker below the drop-down menu. I'm gonna click and drag on the slider on the right to make the tone brighter, and then I want to select a somewhat beige or orange color to make my platform a bit warmer, so it contrasts a bit more with the background. And you'll see the effect will be especially nice once we've added the fog and the materials. Next, we can change the tone map. It's a post-processing effect built into the engine that's widely used in 3D games. So click the tone map category in the inspector to expand it, and by default it's set to linear. We can change it to filmic to make the image a bit more contrasted. This will make the image quite a bit nicer, and then you can play with the exposure to make the light brighter or the image darker, and with the white to change what amount of brightness of the pixels corresponds to white in the image. So usually when you lower the white point, the image becomes a bit brighter and often a bit more contrasted, and as you increase the white point, it becomes a bit less contrasted and a little darker. You can leave the values by default or tweak them to your liking. The advantage of using the ambient light and tone map with a simple color is that this is a very lightweight rendering technique and works great for stylized art like the one we have in this project. Okay, I'm gonna fold the background, ambient light, and tone map categories to focus on the fog. This is the last effect we will turn on, so expand the fog category and turn on the enable property.
That's a lot of
to
fog.
enable the fog. This makes everything gray because now the fog is being applied to the scene and covers the background. So it simulates fog in the scene, and it is more visible if you have more geometry, but we're going to use the fog to give some verticality to the scene, so it's not a problem that we have a single platform. I'm going to pan the view a bit, and first we'll change the light color to be blue. So I'll click the light color, and I'm going to go with a somewhat dark blue, and you'll see it tints the environment only like the sky, because the fog is meant to be like in depth of the screen, but we'll make it vertical. And to make it vertical, we want to change the height property and the height density, the last two sliders. So for the height, I'm going to choose something like 0.5 meters, and height density, we have to increase it to see the effect. So 0.15, something like this. And you'll see now the fog applies vertically on the platform. You can increase the density to make the fog denser, and you can then play with the height. If I click the pin, it goes a bit too fast, but if I click and drag around the top part of the field and then drag left and right, I can change the height of the fog. So you can see the density of the fog changes how tight the fade of the fog is. So I'm going to lower the density a bit to have a nice gradient, and then I'm going to play with the height so that it doesn't go up to the top of the platform, but it does cover the bottom of the platform. And it's going to basically add that nice gradient to all our level. Then let's see what happens if we change the density of the fog. If we increase it, it increases the fog like in the depth axis, I actually don't want that too much, so I'm gonna lower it to a very small value so that the fog is mostly vertical in our level. And I think that's good. We can play a bit with the color to make the sky brighter again, and we are good to go. We can now work on the material of our platform to not make it look flat and bland.
Time to eat your fuel, Michael. Time to eat your fuel, Michael. Time to eat your fuel.
Time to eat your fuel.
Let's add a material to our platform to change its color and control its shading.
Let's
First, select the CSG Box 3D node. With the select mode active, you can click the box in the view. And in the inspector on the right, you will see a material property with an empty slot next to it. This is where we add the material. So click the empty slot and select New Standard Material 3D. The standard material is a resource provided by Godot that gives you lots of options for shading. So it's an all-purpose material that can use in many cases, most of the time actually. Click the icon that you see of the sphere here to expand the material properties in the inspector.
Let's go back.
Standard Material 3D. The standard material is a resource provided by Godot that gives you lots of options for shading. So it's an all-purpose material that can use in many cases, most of the time actually.
That's a lot of values.
The icon that you see of the sphere here to expand the material properties in the inspector, and you will see it has really many options to really fine-tune the shading of objects. Here we're going to focus on the albedo and UV1 for some simple shading to get started with the platform. Albedo stands for the main color of a surface. So expand the albedo category and click the color slot to open a color picker where you can change the main color of the platform. You'll notice that the main color changes and the fog remains unaffected. Also note that when you select the CSG box, there's kind of a blue overlay over it, and this changes the colors that we see. You can see a preview of the material in the inspector on the right, so we could work with that to shade the platform, but it's good to see how it will look like in the view as well, but without the overlay. So to turn off the overlay, we need to change the viewport settings by clicking the perspective menu at the top left of the viewport, and you're going to see a view gizmos option, and you can turn off the checkbox to remove the overlays and the edit handles in the view. So now we have a more faithful idea of what the platform looks like. I invite you to pick a color that you like. I'm gonna go with something blue-green, a little darker maybe, something like this. And next we're going to apply a texture image on top of this color. So the albedo color is going to tint the surface overall. You can combine it with an image that will be projected onto the object that will give it a pattern. You can use the image alone if the image has color information, but you can also use a grayscale image and tint it with the color. This is what we will do here. So in the file system dock, at the bottom left, look for the checkboard image. You can start to type checkboard in the search bar at the top of the dock. You'll find a file named checkboard.png, and you can drag and drop it onto the texture slot in the inspector on the right. And when you do that, you will start to see large faint squares over the surface.
I do.
If they are not visible enough, it might be because of the color, because sometimes if the color is too bright or too dark, the overlay will not work properly. So you need to find a tone where the checkboard pattern is visible, and for that
I can see it.
Medium intensity color can work well. So I'm gonna go with a green, a bit like this. Now, the pattern is really large.
Yes.
So to control how a texture image gets applied to a 3D mesh, we use something called UVs. They are coordinates that map the texture onto the geometry, and they work by unwrapping the geometry onto a 2D plane to tell the computer how to apply the texture image. Anyway, we can fold the albedo category and go down to the UV1 category, which controls the scale of those UVs and the scale of the texture as a result. You can click and drag on the scale slider and increase the scale to make the texture repeat more. This is not increasing the scale of the texture, it's increasing the scale of those UV coordinates, and this is why when the value increases, the pattern doesn't get larger, it gets repeated more times. So that's one way to do things. There's another feature that we can use in here called triplanar. If you turn it on, it's going to change the scale of the UVs. And so we need to lower the value back down. Actually, we can reset the scale back to 1. Triplanar is a really powerful feature built into the standard material that allows Godot to project uniformly the texture from the top, sides, and from the top and sides onto 3D geometry. And this allows you to create a uniform texture mapping around your level, whether you have boxes or round geometry, and to make it consistent everywhere without having to worry too much about this UV thing. So we're going to use it here, and you can see that it really maps the checkboard nicely. And then if you duplicate the box, the pattern continues.
I just realized this is only half. The rest of this is only half the tutorial. It's only half of it. There's another whole half that goes into enemies and stuff, so this is going to be a while.
Perfectly onto the different boxes because of this projection. I think, let me see if we can trigger this. If I go back to the material and turn off the triplanar mapping, you can see that as I scale the UVs, the squares on the different objects have some form of seam, some location where they don't have the same size and they don't match perfectly. If you use triplanar mapping, you don't get that problem, however, because the projection is uniform all across the game world. So this is really suitable for prototyping, for terrains, right? Triplanar mapping, that is. So we're going to turn it off. Notice one thing. So I duplicated my box here, and the material is assigned to both. And then if I change the setting on the material of one of the two boxes, it updates on the other box. This is because materials, and more generally resources that are attached to nodes in Godot, are shared by default. So if you change the settings in one place, it's using the same resource on other copies of the mesh, and so everything will be in sync. This is unlike nodes in the scene dock, which each have their own set of properties. And with that, we have the material, we can add a couple of platforms, and then we can move on with the kill plane and shooting mechanics. In this part, we will create a little level, an arena, for our player to walk. This is mostly to learn to duplicate and move shapes, to do a bit of level design. So, we're going to make different platforms like this one and connect some of them by bridges or with floating platforms. With the CSG Box 3D node selected, you can press Ctrl D or Command D on your keyboard to duplicate the node. A second copy appears in the inspector, and it's selected immediately, so you can move it using the move or select mode. Now, we don't see the handles to resize the platform because we turned off the gizmos when designing the material. So let's click the perspective menu again and turn on the View Gizmos checkbox to bring back the overlays. This allows us to resize the new platform and make it longer, larger. You know, you can make it however you'd like.
This is LinkedIn Recruiter, a hiring tool that helps you hire smarter and faster with over 1 billion global professionals.
This is our...
You'd like. Think of this part we are in here as doing a little platform level, you know, for the player. Okay, so I'm going to make resize the platform because we turned off the gizmos when designing the material. So let's click the perspective menu again.
Right. We want to group these into a platforms node.
And turn on the View Gizmos checkbox to bring back the overlays. This allows us to resize the new platform and make it longer, larger. You know, you can make it however you'd like. Think of this part we are in here as doing a little platform level, you know, for the player. Okay, so I'm going to make large platforms like these. So I'm going to press Control D, Command D, and I invite you in this part to make the level however you'd like. I'm gonna make the platforms pretty spread out. I'm gonna do kind of a square shape, right, for the main level and have some bridges or floating platforms for the player to jump, connecting them. You can do one thing that's very useful. You can go to the perspective menu once again, and at the top of the menu, you have options to change the view. You can use the top view to look at the level as if it was a drawn map from the top down, and it gives you a much better sense of the gaps between the platforms. So I have 3 platforms. I'm going to press Control D, Command D to duplicate the platform again, and I'm going to make this one a bit larger.
Yo!
By clicking and dragging
That is
the dot.
sick.
Sometimes, you know, when you have the select mode active, the circles can get in the way. You can press W on your keyboard to switch to the move mode, or click the icons in the toolbar at the top.
That is awesome.
And so let's say this is kind of what I want, and now I want to add little platforms that are floating between the main platforms.
Yes.
So I'm gonna, again, work from my node. I'm gonna press Command D or Control D to duplicate, and then I'm going to move the platform to be somewhere, you know, in the center of the gap between the other platforms. And then Alt click and drag on the handles to resize my platform. I'm going to do the same in the other axis, and this resizes the platform symmetrically around the center. Now, if
standard material for that one, right? We're going to make it yellow, yeller, Eiler. Yes, we're going to make it that. And then we are going to give it the checkerboard texture. And then the UV we're going to do triplanar for. That's a bit bright, so we might change it to a darker value, like that. Damn, we're doing it. let me move this out of the way. Move it out of the way so you can see what I'm doing. Make it tiny. So yeah, I am now, I don't know if that's too large. I might just do a bit of that. And a bit of that. I test play this, what I've made. There we go. And I've got my level there. Oh, shit. Oh, we've done it. That's so cool. Okay. Now I want to do a platform kind of in the middle. Oh, yikes. Ooh, remember. Look at that. Oh, this is so cool. Oh, I love it. Yes. Oh, shoot. I should really add a reset button to this.
If I use middle mouse click and drag, I'm gonna jump back to the perspective view where I can see that the platform is very tall. You can jump back to the perspective. If I use middle mouse click and drag, I'm gonna jump back to the perspective view where I can see that the platform is very tall. You can keep it like that, or you can make it much thinner to make it look more like a floating platform, right? And it's between the two platforms. Actually, the gap is pretty large, so I think I'm gonna need 2 or 3 of these. I'm gonna make them a bit thinner and duplicate this one. And actually, I'm gonna make them thinner again, because otherwise the player will be able to walk over the gaps because the player has a certain width. Okay, so these floating platforms now, I would like to give them a different color to make them stand out from the rest of the level.
Already
so
done
I'm going
that.
to click one of the platforms and expand to make it a bit brighter of other platforms. If I select my other platform that still has the material shared with the main platforms, if I go change the albedo color,
so good.
it's going to change in sync. So I'm going to save it in the level file as a file that we can edit. In the inspector, right-click on the material and select Save As.
Save as.
This allows us to save the material as a file that we can edit anytime from the file system dock and reuse across scenes. So I'm going to save it in the level file, and I'm going to name it bridge.tres.
Standard material. Yeah, so this is material. So we want to save as in materials.
TRES, the extension stands for text resource, and this is because Godot saves all the data as text while you're working on your project. So if I right-click and select Open an external program, you'll see that the data is all as text. This makes it editable in case you have a problem. This makes it easier to store as
I
part
love
of
this.
version control systems, the systems we use to track changes in a game project and work with a team. And also note that upon exporting the game by default, Godot converts all that to binary resources to make to open the material anytime in the inspector. And you can see that now the material takes the entire inspector, and I can change the properties like the color.
So if I open that, and I mess with the values, aha! I love that.
And it changes anything that's using the material, like my bridge in this case. So now if I select the other bridge, I can click and drag the bridge.tres file onto the material slot. And it's going to use this file for both of the bridges, and I'm going to go back to a yellow color for them. And now everything updates in sync. You can also click and drag the file onto meshes in the game world, and you can see a preview of the material, and you can assign the material this way. We're going to do the same for the other platforms that are currently blue. I'm going to right-click on the material slot, select Save As, and I land in my level directory. And I'm going to save this one as
blue. Why are you making it blue?
It automatically updates every location with platforms platform file. So for this one,
yeah,
I'm
I got
gonna
it, man.
go for green color again. And with that, we have the materials ready for our scene. Now I invite you to run your.
Sorry, I'm just watching. I'm just trying to skip through it.
Radio station with up to 30 artists.
Get through it. Coding the shooting mechanics. Okay, this is the last part of coding shooting mechanics. This is going to be the last part of this tutorial, and then yeah, coding the shooting mechanics is going to be the last part. But then, after that, I believe I then need to move on to creating the mob, which is on their website directly. So I'm gonna have a quick break because I've been recording for an hour and 28 minutes. Okay, quick break, and we'll finish it tonight. Right, I'm back. I've had a coffee. I've registered a domain for realviz.xyz. I am expecting to use it in the future. What for, I'm not entirely sure. What do I mean I'm not entirely sure? I have some ideas. Sometimes you just talk out of my ass. Having a personal website would be great. Adding my domain to my emails, because I currently use Gmail for some things. And because I'm posting everything on YouTube, and Google is just kind of that substantial, I might just stick with Gmail, and it works and stuff. It can get easy to get bogged down in the politics of it all. Hello? What the hell happened? I'm blurry. Cool. I'm back. Sorry, I was like really blurry for a second. No, I'm okay. Cool. So yeah, made a coffee, registered a domain, and I went through the rest of the tutorial. Not went through, I looked ahead to see how much was left, and there's about 3 hours of it, and it's almost 8 o'clock. So we're going to be finishing at 11 p.m. tonight, close to midnight. And then I have to get into uni tomorrow. And that's early in the morning, so. We have got this. We've got this. We're okay. Yes. We are okay. I'm just gonna quickly add something to my notes. Registered with Ionos. I have a note. I have an entry in my notes about my platforms and everything I'm doing business-wise. And it's just keeping track of everything I'm registered with. So I'm just making sure I've got everything right down there. Everyone I'm registered with. Okay, I think that's everything. Or it's everything for the most part. Got everything there. Yeah. Okay. Weird paranoia about being registered. Let's not get into that. Instead, let's get into lost connection. I keep losing connection to the music. That's fine. So, what am I doing? I'm changing to main scene. We have this. GD Quest. I've been following this tutorial. I was following it on YouTube initially, but the rest of the tutorial from 7 to 16 is only on this site. So we are going to be following that. So if I head by, put that in the mini player.
In this part,
I've got it here, right. So we are coding.
We'll set up the gun and the shooting mechanics. There are quite a few steps involved there. First, we will set up the bullet scene. Next, we will place and orient the bullets and their spawning point.
Yeah.
We will code the bullet forward motion so that it moves in the direction it's facing.
Yeah.
We will delete bullets when they travel too far so they don't clutter the game world. We'll make bullets move independently from the gun. We will shoot bullets when the player clicks, and then we'll make bullets shoot automatically at fixed time intervals. With that, you will have a complete weapon, and you'll have learned to spawn things, orient them, and make them move independently from each other. Let's get started.
Okay.
So let's get started by going to Scene, New Scene, to create a new scene, and our bullet will need to detect when it touches a mob. So for that, we will use a special node called Area 3D. Click the Other Node button in the Scene dock and look for Area 3D and create that node. The Area 3D can detect and report when it overlaps with something, which is useful for simple bullets. I'm going to rename this to Bullet 3D just to make the name a bit clearer. As a reminder, to rename something, you double-click the name in the Scene dock, type your new name.
Yeah, I know.
To save the scene as a new file, and we're going to save it this time inside of the player directory. So I'm going to double-click that and save the file as bullet3d.tscn.
We save it in the scenes folder.
You can see a warning sign in the scene dock at the top left.
Which means that there's no
this
collision shape.
Indicates that the node is missing some configuration. Nodes like Area 3D need a collision shape to function, just like the character body 3D we used for the player. So let's
do a
add
sphere,
that.
I think.
Add a new node by clicking this button or pressing Ctrl A, Command A, and look for Collision Shape 3D. In the inspector, we need to set the collision shape we will use, so click the empty slot and then click on New Sphere Shape 3D to create a little sphere. Well, it's not that small actually, although we can't visualize it very well here. The next thing we will add is the mesh that we've prepared for the bullet.
Oh,
the
we've
projectile.
prepared one.
So in the file system dock at the bottom left,
Never mind.
hold the level directory, expand player, projectile, and inside you will find a projectile model.glb file.
Okay.
This is an imported model for the projectile. So you can click and drag it onto the scene, and this will give you an idea of the projectile size. Now, you will notice that it's a bit strange with a black ball at the center and a gray mesh behind that. It's because to give the projectile nice visuals, we prepared that. It's because to give the projectile nice visuals, we prepared what's called a shader program. This shader is going to allow us to control the color of the bullet core and to have a little animated trail around it.
Okay.
So for that, we need to kind of open or expand the imported projectile model by Godot. You can click the Open in Editor icon in the scene dock to do that and see what Godot tells you. It says that the scene was automatically imported, so you cannot modify it directly. To make changes to it, you need to create a new inherited scene. And this is a good opportunity to introduce inheritance in scenes in Godot.
Inheritance.
When you create one of those scenes, like
So
our
much
bullet,
money.
you can create a new scene that will take everything that's present in the bullet 3D scene and add or change things on it. It can add new node or change node settings. And so for imported models, we need to do that to modify them. So let's click the Open in Editor button and select New Inherited. And this will create a new scene tab where you can see the imported 3D model for the projectile in yellow. I'm going to rename this to Projectile 3D and save the scene inside of the player/projectile directory. So I'm going to enter that and ensure that the name is Projectile 3D and click Save. This saves our projectile scene. Now we can access and customize the projectile 3D model that was imported from Blender. In the file system dock, in the projectile directory, you'll find a projectile.gd shader file. It's a program that's used to control the drawing of 3D models and pixels on the screen on the graphics card. Learning how to code that is, again, beyond the scope of a tutorial like that, as it's pretty technical, but we've provided it to change the drawing of the projectile. So we're gonna add a new material to our projectile mesh using this provided shader, because materials like the ones we added to our platform use a shader under the hood.
Oh.
So let's go to the inspector with the projectile node selected, expand geometry, and here you will see a property called material override. The mesh may have a material assigned to it. So the mesh is the 3D geometry of our projectile, and we can change that, we can replace that with the material override property. So I'm gonna click on the empty slot and select not new standard material, but new shader material this time. This creates a material preview like before. You can see that now our projectile is all gray, and we're gonna click the newly created shader material resource to expand its properties and reveal a shader property. This is the program that will be used to draw the bullet. I'm gonna click and drag projectile.gd shader onto the empty shader slot, and now you can see instantly it turns black and the trail starts to animate. You can then expand the shader parameters to reveal the variables, the properties that the person who coded the shader exposed for you to edit the material.
Ah!
So we can change the tail and the head color of the bullet. I'm going to click the tail color, and with the color picker, I'm going to pick a pretty bright yellow or yellow-orange.
That makes sense, yeah.
And for the head color, I'm going to go with a darker orange tone. And with that, we have the bullet visuals. The reason I'm showing you how to create a shader material is because you can find many open source
it's like
shaders
little fire
on this
thing.
website, godotshaders.com. For
Godotshaders.com. Okay.
example, this effect to create an old school TV display. You can click those shaders
CRT
and
effects.
then go find the code right there that you can copy, save in a GD shader file, and then you can use it in a shader material resource as we just did. We also made our own little repository of open source shaders that you can find as Godot shaders on GitHub. You'll find the link in the description, and there are a bunch of demos in this one with the shader materials pre-created in Godot. Back to Godot, let's go back to the bullet scene to see that our projectile did not change. When we created this new projectile 3D scene, we created a new file that's different from the instance of the projectile model we had added to our bullet scene. So now in the file system doc, we can locate the projectile 3D scene, and we're going to drag and drop it onto the bullet node. This is another way of instantiating a scene. And we can select the old projectile model, press delete on the keyboard, and confirm that we want to delete the node.
Nice.
And with that, we have the projectile visuals. We have one more thing to change. The collision shape for the bullet is a bit big compared to the model. And in general, you'll do something like this when creating areas or collision zones. You'll first create the area and the node setup, then add the model, and then you can change the collision shape to match the model. Now, with snapping on, the increments to resize the collision shape are a bit big. So you can press Y on your keyboard or click the snap icon in the toolbar to toggle snapping off, and then click and drag on the collision shape 3D handle to resize it. You can make it a little bit bigger than the 3D model to help the player touch enemies and damage them. But you don't want it to be too big, or sometimes it will look like you've damaged enemies without even touching them. With that, we are ready to add the spawning point to the gun and make it shoot bullets.
Nice.
We have to head to the player scene where the gun lives. So let's open the player scene, and I want to show you a new trick. On your keyboard, you can press Ctrl-Shift-O or Command-Shift-O to open the Quick Open Scene Picker.
Ooh.
This allows you to search all the scenes in your project very quickly and press enter to open the selected one. So if I start typing player, I'll find player.tscn, and I can press enter to open it. This is equivalent to going to the file system doc and going down to the player folder, locating player.tscn and double clicking it. Now I'm going to select the gun model in the view to see the gun, and what I want to do is to tell Godot where the bullets should spawn from. And for that, we can create a new node that will place as a child of the gun and place in front of the gun. So let's create this. It can be a child of the camera or the gun model. It's the same thing. It just has to move with the camera. So I'm going to select the camera 3D node.
Hang on, I think I fucked something up. No, seems okay. Okay, I'm just gonna, I think I'm gonna rotate my player around so that they are facing that way when they spawn.
node and press Control A, Command A, and add a new marker 3D node. This is a plain 3D node, marker node, and press Control A, Command A. So I'm going to select the camera 3D node and press Control A, Command A, and add a new marker 3D node. This is a plain 3D node with a location, rotation, and scale that draws a little marker in the 3D view, so it's perfect for spawning points. Select the marker 3D node and move it until it is in front of the gun nose. You'll want to turn the camera to see that, because depending on the perspective, it can be difficult to place it accurately. So it's normal if you have to turn the camera several times and adjust until the node is right in front of the gun. Okay, so you want this.
Oh, look at that. So smart. And where do we want it? We want it
until the node is right in front of the gun.
Right in front of the gun.
Okay, so you want this.
You want it like that. Okay. So let's push you kind of like right there, I guess.
Cross here to be at the entrance of the gun. Because we'll see the gun from the back, it's okay if there's a bit of space between the gun and the marker, right? You will not see it. This is just where the bullet will spawn. You can test the effect by selecting the marker 3D node and creating a bullet 3D instance as a child of it. So you can click and drag the bullet 3D scene onto the marker 3D node to create an instance, and you'll see it'll be rotated the wrong way and way too large, so we will adjust that in a moment. I'm going to press Command Z or Control Z to undo. I want to show you another trick though to create scene instances. With the marker 3D node selected, you can click this Instantiate Child Scene button at the top left of the scene dock, or press Control Shift A, Command Shift A on Mac, and this opens the same search window we had for quickly finding and opening a scene. This time it's to create a scene instance, and so you can look for your bullet 3D scene and press Enter, and this will instantiate the bullet as a child of the selected node. So this is a very powerful trick to quickly add things to your scene when working on a large Godot project. So the bullet is too big and it's not looking in the right direction. As I think I've mentioned before, we need the bullet to face along the Z axis like this, but the model of the bullet is facing towards the positive X axis. So we can go back to the bullet 3D scene and turn the bullet around and also scale it because it's way too big. So click the icon to open in the editor next to the bullet 3D scene instance to jump to the bullet 3D scene. And we can see if we select the projectile 3D instance that it is facing towards the red axis, towards the right. And instead, we need the projectile to be facing towards the negative Z axis, which is the forward direction. So for that, select the projectile 3D node, and with the select mode or the rotate mode active, you can rotate the bullet. You'll want to turn snapping back on to snap to 15-degree angle increments. So I'm gonna press use snap here and rotate around the vertical axis to turn the bullet to face along the blue line. The next thing I want to do is scale it down. For that, I can use the scale mode in the toolbar. You can press R on your keyboard to turn it on, and you can click and drag then anywhere in the viewport to change the scale. So I'm gonna make it about half the size, or a little bigger than that, 40% smaller. And then I'm gonna select the collision shape 3D node, and I'm gonna go back to the select mode and click on the handle, I'm going to press Shift, and then I'm a little bigger than that, 40% smaller, and then I'm going to select the bigger than that, and press R on your keyboard to turn it on, and you can click and drag then anywhere in the viewport to change the scale. So I'm going to make it about half the size, or board to use the scale mode in the toolbar. You can press R on your keyboard to turn it on, and you can click and drag then anywhere in the viewport to change the scale. So I'm going to make it about half the size, or, a little bigger than that, 40% smaller. And then I'm going to select the collision shape 3D node, and I'm going to go back to the select mode and click on the handle. I'm going to press Shift on my keyboard to make the collision shape a bit smaller. Actually, I'm going to turn off snapping again, zoom in, and click and drag on the handle to make the sphere a bit smaller. Okay, now if I save the scene by pressing Ctrl S on my keyboard and go back to the player scene by clicking the player scene tab, now we see the updated bullet. Well, it's still way too big, so I'm going to make it smaller again, go back to the scene, select the projectile, and I'm going to, with scale mode, make the node smaller again. This time I'm going to save, go back, and yeah, the size is about right. It does not leak outside of the gun. It's pretty big, but as it moves in the distance, it's going to be less and less visible, so I'm going to keep this size and go back to the bullet scene, select the collision shape again, and resize it to fit the bullet node. Now that we checked the size of the bullet, we're going to add some code to make it shoot forward. Automatically, it's just going to move forward, and then we will move on to coding the shooting mechanics when the player clicks.
Okay.
Before we get coding, let's clean up some of the scene tabs that we have up there. To do that, you can click the tab that you want to close, revealing its close button, and then click the close button. You can also middle mouse click. For example, the projectile 3D tab, I'm going to middle mouse click, and it will close instantly. With that, we can attach a new script to the bullet and get coding. So select the bullet 3D node, click the attach script button at the top of the scene dock, and create the script in the default location. Our script extends area 3D. This is the type of node we created for the bullet 3D node. And this gives us some nice features to detect when the bullet is touching something. This will allow us to damage enemies. Now, for now, we're mostly going to move the bullet first. And for that, we will define two constants for the speed and range of the bullet, and then move it forward. So to define constants, which are names given to values in our code, we can type const, then I'm going to name it speed and set it equal to 55 meters per second. I'm going to add a second one for the range of our bullet, like how far it can travel before it gets deleted. It's going to be 40 meters.
Yeah.
And to keep track of how far the bullet traveled, I'm going to define a variable, which we can change each frame. So I'm going to call it var traveled distance. And with that, we can move the bullet forward. To move an area or a physics body, we want to use the physics process function. It allows us to synchronize the simulation between the player and the bullet and everything happening with physics in the game. So let's define the function by writing func underscore physics process, and you'll get auto completion. You can press enter to confirm. In this function, we're going to change the position of the bullet each frame. As for the player, before, we need to move the bullet forward based on where it's looking. As a reminder, if I go back to the scene, if I rotate the bullet, its axis, its forward direction is going to turn with it. And in code, we can access the right, top, and front and back axes of the node using the transform.basis property.
Yes.
We can add to the position each frame, and if we go back to the scene, the forward direction of the bullet is not positive z, it's the minus z axis. So I'm gonna add minus transform dot basis dot z. This is the direction, and we can multiply that by the speed multiplied by delta. Speed times delta represents how much we want the bullet to move in one frame, and the transform.basis multiplies that to move the bullet in the direction it's facing. Now, if you go click the Run Project button at the top right of the editor, you're going to see the bullet go forward. It's moving forward relative to the gun, and this is why we had a bullet instance in the player scene, to be able to test it. Now, if I run again, you can see the bullet keeps going. Probably it disappears in the video, but it is still there. If I go back to...
I'm going to make that bar slower. Is it Z? It is negative Z, okay. Well, that was the wrong way. I want it to move in positive Z, not negative Z. Wait, what? Ugh. Well, because it's still a thing of the player. Oh wait.
Godot.
So I don't want it to travel Z.
And look at the scene dock, there are two tabs that appeared, remote and local. If I click the remote tab and I expand the nodes, I can see a video, but it is still there. If I go back to Godot and look at the scene dock, there are two tabs that appeared, remote and local. If I click the remote tab and I expand the nodes, I can see a view of the nodes at runtime in my running game. I can see where are scene instances and what nodes they contain. So if I expand the character body 3D node, which is the player instance, and the camera and the marker, I can see that my bullet is still there. It stays there. And if we make the player shoot bullets really fast, they're going to accumulate there and eventually slow down the game. So we want to delete the bullet when it reached a limited range. So back to the bullet script, I'm going to increment the travel distance each frame, and once it is higher than the range, delete the bullet. So first, we increment the travel distance.
It's not doing it right.
Going to write the variable plus equals to add to it, and the travel distance is speed times delta. We don't need to keep track of the direction, we just want to know the number of meters traveled by the bullet regardless of the direction.
Let me make a new one called delta speed equals speed times delta. New variable called Why is it doing that? Why is it doing that?
It was in. Then I'm going to use a condition. If the travel distance is greater than the range value, I'm going to destroy the bullet. And to do that, we call a function named queue_free.
Yep,
it's a function that
queue_free.
deletes a node. And it happens only...
What happens if I change that to like X? This is a terrible way. I don't like this because it's a child of the player. I don't know what I've done differently, but it's a child of the player, and wherever I look, it's just going to follow. Now, granted, I have slowed it down tremendously. It's probably way too fast.
If that condition is true. With that, if I run the project, the bullet is going to disappear after a while. I can confirm this by going back to Godot, heading to the remote tab, and if I look at my expanded player scene, camera, and marker, you can see that the marker does not have a child bullet. So it confirms that the bullet was deleted. Now I want to show you a very common and important gotcha. Look at what happens if I lower the speed of the bullet and run the scene, and now when I turn the view, the bullet turns with it. This is because the bullet is a child of the camera. So if I go back to the player scene and to the 3D view, you can see that the bullet is a child of the marker 3D, that's a child of the camera. So if I offset the bullet and I rotate the camera, child of the camera. So if I offset the bullet,
because my dimensions are different. I guess that's fine. But why is it X? There's got to be a better way to do this. A way that makes sense to me. So it has a position. The bullet has a position. It has a position dot X, but it also has a position dot Y, so it's got to move negative Z. So position dot Z minus equals delta speed. I don't know why we don't just do that. He probably explained it.
And I
I've
rotate
forgotten.
the camera, the bullet rotates with it. There are a couple of options to avoid this problem. We can, in our code, make the bullet a child of a different node that is not part of the player scene, so that the bullet does not rotate with the camera. Another option is, in Godot, to select the bullet 3D instance and go to the inspector, to the transform category, and go down and check top level. This is going to make the bullet node move independently from its parent, even if it is a child of the...
Y'all? Ah! Look at that.
If we run the scene with this option on, you're going to see now the bullet moves independently from the camera. The view is a bit bugged because, well, when you use this feature in your code, now the position of the bullet, everything is independent from the camera. So you need to use code to make sure that it is moved to the position of the marker. But we will do that when we add the shooting mechanic next.
Okay.
Note that it is not enough to change the top level property on the instance of the bullet. This changes the property only on this bullet inside of the player scene, but we want every bullet the player will shoot in the game to have this property. So for that, we go to the source scene, which is kind of the template or reference for every bullet the player will shoot. So click the bullet 3D scene tab at the top of the viewport, select the bullet 3D node, and in the inspector, we go down to the transform category and turn on top level. Okay, with that, we can save the scene, and we're all set to start coding the shooting mechanic.
Okay.
In this part, we're going to write the code to shoot bullets. I'm first going to delete the bullet instance we have in the scene because it's a placeholder for testing. So select the bullet 3D node, and then I'm going to press Shift Delete on my keyboard, or you can select it in the scene dock and press the Delete key and confirm to remove the scene instance. Then we can go to the player script, and at the bottom of the script, we're gonna add a new function that will shoot one bullet. I'm going to call it shoot_bullet. In this function, the first thing we need to do is to create a bullet instance. This process involves a couple of steps. When you click and drag the bullet scene onto your scene dock or onto the game world, Godot loads, creates an instance of the scene, and adds it as a child of either the player or the node onto which you drag the scene. In code, these are 3 different steps that we need to code. So first, we need to load the bullet scene from the file system. For that, we can use a function called preload. This is a very handy function that loads things as soon as the game is running. And we need to pass the path to the bullet to the function to load it. For that, you can click and drag the bullet 3d.tscn file from the file system doc into the parentheses, and when you release, it inserts the path to the file. You actually don't have to do it like that. You can let Godot create a variable, a constant for you with the preloaded scene. For that, you remove the line and you click and drag the bullet 3d.tscn file. And before releasing it, you press the control or command key on your keyboard down and you release. And it's going to insert a new constant that is named and that holds a reference to the loaded scene. A common question when seeing this code is, okay, but we're going to call this function shootBullet each time the player shoots a bullet. Aren't we loading the file every time? And the answer is no. Godot is only going to load this file once and virtually replace the function call with the loaded resource. Actually, when you load things in Godot, it smartly load them once, and as long as they stay in use, it keeps them in memory. Now we can create an instance of the bullet by writing bullet3d.instantiate. Instantiate is a function that's part of loaded scene resources, and we can store the newly created instance in a variable to do different things to it, like moving the bullet, adding it as a child of another node, etc. So I'm gonna define a new variable called new bullet, and it's gonna be equal to bullet3d.instantiate. Below that, I told you the third step is to add it as a child. So we're gonna add it as a child of the marker 3D node. as we did before for the camera, we're going to make this node have a unique name. So we right-click the marker 3D in the scene dock and select Access as Unique Name in the drop-down menu. This allows us to write person sign marker 3D in our code to reference the marker 3D. Then we can write a dot to access the node's functions and call add child on it to add the bullet as a child of the marker. In parentheses, we're going to pass our reference to the new bullet, which is in the new bullet variable. So this is going to create a node and add it as a child.
My
of the
bad
marker.
for thinking it was going to autofill.
As mentioned right before, when we do that, now that our bullet is stored as top level, it's going to not move the bullet to the marker.
It's just going to be a child of it, so we need to set the transform.
And not only that, the player is going to move and rotate in the game world. So we not only want to move the bullet to the marker, we also want to orient it to the marker. And we can do that with one line of code. So back to the script, we're going to add a new line after adding the bullet as a child of the marker. And it's going to be like this. We're going to write new bullet dot global transform is equal to marker 3D dot global transform. The global transform represents the position, rotation, and scale of a node or an entity in a single value. This is how game engines usually handle moving, rotating, and scaling things under the hood, and these are available to you. We could use several lines of code to change the position and rotation separately, but we can use this value that's quite convenient. So this says, take the position, rotation, and scale of the marker and assign it to the new bullet. So basically, move the bullet and rotate it and scale it like the marker, but the marker is not scaled, so it's just going to move the bullet and rotate it to the marker. At this point, we can already start coding the shooting mechanic. We'll add more to the function in a moment, but let's go back to the physics process function, and at the end of it, we're going to add code to shoot the bullet. First, we need a new input action to represent shooting, so we're going to go to Project, Project Settings, Input Map, and in the new action bar, I'm going to type shoot, and then click the plus button to the right of the action, and you can actually click inside of the bar that says listening to input, and it's going to detect the left mouse click.
I think I'm getting ahead of myself.
OK, and close. This allows us to use our new shoot input action. And how do you think we can write the code for the shooting mechanic? Try to pause the video and do it yourself as a short exercise.
Oh, it's just right there. It's right in front of me. Shooting. We have if input dot is action just pressed shoot bullet. Now I'm going to run this and see if that does actually do it. That's nearly it. Ah.
And I'm going to give you the solution now. So we can write if input dot is action
I did that.
just like we did for the jump.
Broken.
But this time in
global transform
we're gonna
of the new bullet
pass our shoot
the transform of the marker. So it should just match. Right, so da da da. Why is it horizontal?
Put action, colon, and then we call the shoot bullet function. This is going to create a gun or rifle-like shooting mechanic where the player clicks once to shoot one bullet. We can run the game by clicking the Run Project button at the top right, or in my case, pressing F5. And when I click, it's going to shoot one bullet that moves forward. It's going to move up to a certain distance, and then it's going to get freed automatically.
I think it's because I didn't do the transform.basis in here. Because it's just changing the Z of it. So I do that instead. What the hell? Is it working now? Ah! Okay, well... Oh, wait, that was just for debugging.
And no.
But it should be... Top level should be on. I don't know why it's not on. Okay. Cool. That's working. The transform's a bit messed up. So, do I need to fix it to that? Okay, I fixed it. Did I fix it? I think that's fixed it. Okay. I don't know why my code is being so weird, but...
Note that you can go back to the Bullet 3D script anytime. You can double click it in the file system doc if needed and change the speed to a value like, 20 is going to be a bit better. And then when you click, the bullets are going to move much faster and disappear when they get to the maximum range. Now, currently, to shoot the bullet, I have to click each time individually. What if you want the bullet to shoot automatically when the player keeps the mouse button pressed? For that, we can use a timer node. So, in the scene doc, select the player node and click shoot automatically when the player... What if you want the bullet to shoot automatically when the player keeps the mouse button pressed? Well, for that, we can use a timer node. So, in the scene doc, select the player node and click the plus button to add a child node. And you're going to look for the timer node and press enter to add it. The timer node is going to cycle by default for 1 second, as indicated by the wait time in the inspector. And each time it cycles, it's going to emit a signal, a little message that we can react to called timeout. We're not going to use this property of the signal in this case. We're going to turn on its one-shot property, which makes it not cycle. Instead, it plays once, and we can check if it is stopped or active to know if the player can shoot a bullet or not. The wait time is going to be our cooldown time between the bullets. So for example, if you want to shoot 1 bullet per second, you set the wait time to 1 second. If you want to shoot 2 bullets per second, you set the...
Let me see what he could for Ghost Code.
Press... And you're going to look for the timer node.
Yeah.
And press enter to add it. Case. Cycle. Instead, it plays once, and we can check if it is stopped or active to know if the player can shoot a bullet or not. The wait time is bullets per second. You set the wait time to 0.5 seconds, and so on. The lower the wait time, the more bullets the player can shoot. I'm gonna go with something like 0.2, so around 5 bullets per second. With that, we can start using the timer in our code. So I go back to the player.gd script, and to access the timer, I'm also going to right-click the node in the scene dock and select access as unique name. And then in the shoot bullet function, each time we shoot, I'm going to start the timer. This is going to make it run for 0.2 seconds, and then we'll make sure that while it's running the timer, we prevent the player from shooting in the physics process function. But first, in the shoot bullet function, I'm gonna add a new line, write $sign timer dot start. It's a function of the timer that starts it, makes it run for the duration of wait time. And so with that, we can now check if the timer is active and our physics process function to change the shooting mechanic. So first, we're not going to only check for when the action shoot is just pressed. Instead, we're going to use a different variant of the function. It's is action pressed. This function is going to be true and pass the condition as long as the shoot action, so the left mouse click, is pressed down every frame. So if we just use this one and I play the game, you'll see I'm shooting loads of bullets. This is because each frame the condition is true and I'm shooting a new bullet. So we need to add more to this condition to limit the shooting mechanic. So after this first condition, I'm gonna add the AND keyword to combine it with a second requirement, and I'm gonna get my timer node with $timer dot, and it has a function called is stopped. If the timer is stopped, it means it's not running, so the cooldown time is passed and we can shoot a new bullet. And I'm going to run the game, and now when I keep the mouse button pressed, I'm shooting bullets automatically. Cool. Notice that I'm still running the temporary level that I was showing at the start of the project. So I'm gonna actually set our new level to the main scene so that pressing F5 in my case or clicking the run project button plays our level. For that, from the file system doc, you want to locate your game scene, your game level, and right click the file and select set as main scene in the menu. You'll see the file name turn blue. This indicates that when we click the run game or run project button, it's going to run this scene. Okay, great job. We're more than halfway through. We now have an environment.
We're more than halfway through. Are you sure about that?
A gun, a first-person character controller that can move, jump, aim, and shoot. Not too shabby. All right, let's keep going.
I will also say, the physics process for the bullet. I'm gonna put a note up here. Say, bullet currently passes through collisions or the CSG box platforms would like them to queue free when they collide.
In this part, we will work on the mob. We will make it follow the player around. The mob will push you and try to push you out of the terrain, and you'll be able to shoot at it, damage it, and kill it.
Let's get started. Cool.
Started. In this part, we will work on the mob. We will make it follow the player around. The mob will push you and try to push you out of the terrain, and you'll be able to shoot at it, damage it, and kill it. In this part, we will focus on the animation. We will create the mob scene and prevent it from falling. We will make the mob play its fly animation. Design the mob's take damage animation.
Okay, before I do that, I'm gonna check just everything is fine in the house. Hello. I'm back. Don't know if you can hear that. I'm just charging my headphones. Hopefully that's not too bothering.
Layer animations in an animation tree so that the mob can play its hurt animation while it's flying. And finally, we will play the hurt animation when a bullet hits them.
So, create mob scene, prevent falling, play the fly animation, design mobs take damage animation, layer animation, animation tree, and play the hurt animation when a bullet hits the mob.
Back to my game scene. I've closed the tabs for other scenes because we don't need them anymore, and we can create a new scene to represent the mob. So I'm going to click the plus icon above the viewport, which creates a new empty scene. And for the root node of the mob scene, I want to represent the mob. So I'm going to click the plus icon above the viewport, which creates a new empty scene.
Oh, okay.
And for the root node of the mob scene, I want to use a rigid body 3D node. So click the other node button in the scene dock to open the create new node pop-up and search for rigid body 3D. This is a node that is automatically moved by the physics engine, and we can use it to make the mob fly when we kill it. You'll see that in a second. The next thing we're going to add is a placeholder of the mob model. So for that, in the file system dock at the bottom left, expand the mob directory and the bat subdirectory, and click and drag batmodel.glb onto the rigid body 3D node. This will add the bat to the view. I'm also going to toggle the preview environment back on again. And I'm also going to toggle the preview environment back on again. And we will change this in a moment, but having the model helps us to add the collision shape to the rigid body 3D node, because all physics bodies, all physics nodes, areas and character bodies and rigid bodies need a collision shape to function. So reselect the rigid body 3D node and add a new collision shape 3D node as a child of it. This will be what we use to detect collisions between the player and the mob, and also to hurt the mob. With the collision shape 3D node selected, in the inspector, click the shape and select new sphere shape 3D. The default size is a bit big, so I'm gonna expand the sphere shape and click and drag on the radius field to change the size of the shape so that it's just a bit bigger than the bat's body. So that it's just on the radius field to change the size of the shape so that it's just a bit bigger. So I'm gonna expand the sphere shape and click and drag on the radius field to change the size of the shape so that it's just a bit bigger than the bat's body. Firing at the wings should not necessarily hurt the mob, at least I'm gonna go with this, but feel free to make the sphere bigger or smaller or to adjust it later. With that, we have our mob. I'm gonna rename the rigid. With that, we have our mob. I'm gonna rename the rigid body 3D node to mob for a more descriptive name and save the scene. Press Ctrl S or Command S on your keyboard
saved there.
And save the mob scene inside of the mob folder as mob.tscn. Alright, so we can now instantiate the mob scene in our game scene. So I'm gonna go back there, and in the file system dock, I'm gonna look for mob.tscn and drag and drop it onto the game world. It gets instantiated on the floor.
Okay. So let's take our mob.
So I'm gonna move the mob up and center it maybe on the bridge. Okay, so first thing you can see is there's no shadow behind the mob. And this is because when we created our directional light, we didn't turn on shadows. By default, shadows are turned off in 3D game engines for lights because they have a performance cost. So you opt in to adding shadows to specific lights. Select the directional light 3D node, expand the shadow category in the inspector, and turn on the enable checkbox to enable shadows. And we'll see shadows behind the mob and the player. Whoops. So now we can run the game scene and try to guess what will happen to the mob. Will it stay up there, do nothing, or will something else happen? Well, let's try out, and we see that it falls. This is what the rigid body 3D node does. It makes the node move automatically under the effect of gravity, and it can be affected by other forces. By default,
Okay. I think I need to take the gun marker and that and rotate it ever so slightly. Nope. That's a bad idea. That's terrible. That aiming's awful. That's fine tuning for later.
we can't really push it or do anything without adding a bit of code at least, but it will have the effect of gravity and stop when it touches the ground. Now we want the mob to fly or to at least hover over the ground, so we're going to turn off this gravity. We'll use the rigid body. Just when we kill the mob, we'll apply a sort of random force to make it fly away and roll on the floor. So let's go back to the mob scene and select the mob root node. And in the inspector, you can see a property called gravity scale. This is what controls how much the gravity. Go back to.
Hang on. Shadows enabled? I think so. Energy's a bit intense. If I change the directional light. Yeah, I'm just playing around with the settings here. Boo! Right.
To the mob scene and select the mob root node. And in the inspector, you can see a property called gravity scale. This is what controls how much the gravity gets applied to the mob. So you can set this to 0 to ensure that the mob does not fall, that it doesn't move right now. One problem we have when running the scene is that the bat does not play any animation. So let's make it fly next. Head back to the mob scene, and in there we have
animation
our
player
bat model instance that looks like a scene, but actually it's an asset exported from a 3D art program that Godot imported. So if you click the open in editor icon in the scene doc, you'll see a pop-up that says the scene was automatically imported, so it can't be modified. To make changes to it, a new inherited scene can be created. The file we used to make this bat model instance has the GLB extension. This is a 3D file format that you can import in the Unreal Engine, in Unity, in Godot, and so on.
Graphics
it's
library.
Something made by an artist and
Binary.
not a scene designed in Godot.
Maybe? I don't know.
Godot imports the file and kind of converts it as a scene, but it doesn't let you edit it directly. The reason is that it's very common to need to adjust and re-import these 3D models. So any changes you would make to a scene imported by Godot might be lost. You can see the structure that Godot creates for you by right-clicking the bat model in the scene dock and selecting Editable Children. This option reveals the structure of the scene.
Okay.
It shows the internal nodes in yellow to indicate that you cannot delete these nodes. You can override some of their properties, but you cannot really change the structure of the scene.
He does!
From
He flies!
the DLB file, it created a bat mesh instance. This is the 3D model. A skeleton. The skeleton is the armature that animates the model.
God.
And an animation player node that contains the bat animation. When you select the animation player, the animation bottom panel appears, and in it you can see the animation of the bat flying called idle. You can click the play button to play the animation, and you'll see that when you do that, the animation plays just once and then stops. So the animation is not looping automatically. Usually when you create an animation directly in Godot, you can click this looping icon at the top right of the animation bottom panel. If you try to click it here, you'll get a pop-up saying that you can't change the loop mode because the animation is, big quote, embedded in another scene. In this case, this is supposed to mean that this was imported from a 3D model, so the animation doesn't come, hasn't been designed in Godot, so we won't let you change its settings directly. So if we want to loop the animation, we have to use another approach. When you import a 3D asset in Godot, you can change its import settings by going to the GLB file. So in the file system doc, navigate to the batmodel.glb file, and you can then double-click it or right-click and select Open Scene to open the advanced import settings for the bat. There, you can see the node structure that Godot creates from the data it found in the imported file and change settings. You can skip importing anything you don't want. You can generate some collision shapes or stuff like that from 3D models. And you can see the animations it imports below the animation player. If you select the idle animation, on the right, you'll find the loop mode setting. Click it and select linear to make the animation loop. You can click the play button to preview the selected animation, and you will see that after changing the loop mode, the animation loops. We can click re-import to re-import the animation, and now the loop mode is activated in the animation editor. If I press play, you'll see that the bat flies in an infinite cycle. Great. So the takeaway is that when you import a 3D model, there are a bunch of settings that you have to change in this import window that you get from...
I doubt I'm going to have to actually edit any animations. So...
the imported 3D file. To make the animation play in the game, we need to turn on the autoplay on load icon at the top of the animation editor. So click it, and you'll see an icon appear next to the idle animation. This indicates that as soon as the mob appears in the game, it will play this animation.
He's doing it.
You can go back to the game scene and press F6 to run the game, and you'll see that now the mob animates and is flying. Cool. Next, we can add an animation that shows when the bat gets hit by a bullet and that hurts it. So let's go back to the mob scene, and we have...
You know what? I'm very quickly going to... Instead of making the mouse visible, I'm just going to make that end the scene. So... How do I do that? end scene. Notes and scene instances, player scene and input actions. Manual. Scenes, physics network, best practices, editor introduction. Thanks.
Have
I'll do
made
that
the
later.
children of the mob editable, but we can't really create a new animation to show when the bat is hurt, and we need to add that. So I want to show you how to layer an animation on top of the imported ones. So we're going to replace the bat model, and we're going to create an inherited scene for it, which is necessary to expand the bat.
Okay.
So click the open in editor icon in the scene dock to bring the pop-up that invites you to create a new inherited scene. Once you click it, you're going to see something similar to what we have in the mob scene with editable children. You're going to see the imported structure of the 3D model in yellow, and you can add nodes to that. You're going to be able to make changes, but this is now part of a new scene, and we're going to save the scene in the mob bat subdirectory as batmodel.tscn. So this makes it a scene that we can use to replace the bat model in the mob scene, because
I think I'm realizing that maybe keeping the scenes with the mobs and the player with the player is it's a better idea when the project gets a bit big, because I guess it depends on how you want to structure it. If you're looking for a scene. If you're approaching it from a technical perspective, you do it this way, but if you want a more design perspective, maybe I'm talking out of my ass, I don't know.
what we have in the mob scene is an instance of the batmodel.glb file, the auto-imported one, not our new scene. So I'm going to delete this bat model by pressing Shift Delete on my keyboard, and click and drag the batmodel.tscn onto the mob node to create an instance of my scene. That way we're sure that this bat model will have the code we will attach to it, and also the animation we're going to add. Okay, so one thing I want to do in there with my mob is to make it flash red and scale up and down when it takes damage. So let's create the animation and build the parts one by one. Select the animation player node to display the animation bottom panel. You can also click at the bottom of the screen to toggle it on and off. And then go to the animation menu, and you're going to see you're not able to add animation. So you need to add a new library. I'm going to call it custom, and we can add new animations to it. Just to explain, when you see this animation library manager, what you're seeing called global at the top left with the idle animation is what is imported with the model. So you can't directly change these animations because they come from the imported file.
It's baked
so you
into
need
the
to
file.
create a new animation library. It's a set of animations that you can save to the disk and potentially reuse between different characters and scenes in your project. So you need to create a new library where you will add your own animations. And so you can click the plus button to add an animation to the library, and we're going to name it Hurt. It's going to represent the bat taking damage. And you can click OK. And now when you click the drop down that says idle, and that shows the idle animation of the bat, you will see your custom/hurt animation. This is the newly created animation, and we can get scaling and animating the color of the bat. So for the scale, I'm going to select the bat mesh here, and I'm going to animate its scale. So when you have the animation editor showing up, you can click the Add Track button or go to the inspector with a selected node and click the key icons that appear everywhere to add animation steps, keyframes we call them. And it represents how we want the scene to be at this point in time in the animation timeline. Let's use it and you'll see in practice how it works. So I'm going to expand the transform category in the inspector and go down to the scale and click the key icon next to the scale. So Godot is going to bring a pop-up by default asking if you want to create a reset track, and you want to say yes. The reset track is there to set the default state of your model, of your bat in this case, and it is how it should look like when it's not playing any animations. So we have a first keyframe and we need another one to see the animation. So click the timeline at the top of the animation editor, the gray area, to move the current point in time to 0.1 seconds, for example. And then we're going to modify the scale in the inspector. So we're going to scale the bat up a bit. You can click and drag on the field to do that. And then click the key icon again. And once you've...
Animation is where it gets a bit tricky for me.
In the inspector, so seconds, for example. Okay. And then we're going to modify the scale in the 0.1 seconds, for example. And then we need to look like when it's not playing. Any animations. So we have a first keyframe and we need another one to see the animation. So click the timeline at the top of the animation editor, the gray area, to move the current point in time to 0.1 seconds, for example. And then we're...
Wait, how do you do it?
You want to say yes. The reset track is there to set the default state of your model, of your bat in this case, and it is how it should look like when it's not playing any animations. So we have a first keyframe and we need another one to see the animation. So click the timeline at the top of the animation editor, the gray area, to move the current point in time to 0.1 seconds, for example. And then we're going to modify the scale in the inspector. So we're going to scale the bat up a bit. You can click and drag on the field to do that. And then click the key icon again. And once you've done that and you click and drag over the timeline, you're going to see the scale of the bat change.
Okay.
Now,
there's no there is no I'm gonna assume there's one. And it's
now the keyframes are kind of like steps to hit for the animation system.
Oh, is there?
But if you click the play button, you're going to see the bat animate. You can press Shift D on your keyboard to play the animation from the beginning each time. And so we can add another keyframe like this that's going to scale the bat back down to its original size. So I'm going to reselect the bat node and reset the scale down to 1. So I'm going to click the field, type 1, and press Enter, and click the key icon. And it's going to insert a third keyframe. So now our animation has 3 keyframes, and it scales the bat up and down. Okay, so that's nice. It suggests a reaction to something, but it would be nice to make the bat red when it takes a hit so that it's a bit more clear than it's hurt. To animate the color of the bat, we need to animate its material. It's what...
I'm going to move that keyframe closer to there. Where are the curves? I know I can do curves in here. I'll just keep it to what he has.
Defines how it interacts with the lighting
Oh, easing,
and its
right there.
color.
I was looking for easing. I like that.
What makes its wings
Cool.
purple and its muzzle pink.
Muzzle
So
pink.
let's select the bat node and scroll up in the inspector to the mesh property at the top. This mesh property represents the 3D model's geometry. And if you click to expand the mesh resource, you're going to see, first of all, that everything is grayed out, so you can't edit the properties. And if you expand the surface 0 inspector category, you'll see the bat material. So this is what controls the color of the bat and what we can use to make it turn red. The thing is, we can't edit it. It's grayed out, as you can see. So we need to extract that to make it editable. Here is the simplest way to do that. You can right-click the material and select copy. This allows you to copy the material resource. And then you expand the surface material override section of the inspector, right-click the empty slot and select paste. And it's going to create a reference to this material that is now editable. We're not only going to do that, we're also going to right-click this copy of the material and select Save As. This will allow us to save it as a file that is kept for sure in our project files and will not be overwritten when you re-import the model. So select Save As, and we're going to save it in the bat folder as bat_material.tres, T-R-E-S. And now our bat material is in our project folder. I can go back up and fold the mesh property and edit my material. So in the material, you have lots of properties, and we're not going to go through them all here, but you can expand the albedo property. And when you click the color slot, you can select a different color, and it's going to tint the 3D model. So you can use that to color the model and animate this property. The texture is what gives the bat its different colors. A texture is an image that's applied to the 3D model. And this one is very simple. It's just a bunch of colored squares applying to different parts of the 3D geometry. Okay, so let's animate the color of the bat. So make sure that your time cursor is at the start of the hurt animation.
Yep.
And click the key next to the color property. It's going to bring the pop-up again, asking.
So I need to go to my, that's the very start.
If your time cursor is at the start of the hurt animation, and click the key next to the color property. It's going to bring the pop-up again, asking you if you want to create a reset track. You can say yes, create. Move to 0.1 seconds in the animation timeline. Then we're going to change the color. So
what has happened?
property. It's going to bring the pop-up again, asking you if you want to create a reset track. You can say yes, create.
Select the bat, go to here.
Move to 0.1 seconds in the animation timeline. Then we're going to change the color. So click the color slot to bring up this color picker, and you're going to click and drag until you expand the albedo property. And when you click the color slot, you can select a different color and it's going to tint the 3D model. So you can use that to color the model and animate this property. The texture is what gives the bat its different colors.
I don't know
the
why
texture
it's
is an
not working.
image that's applied to the 3D model. And this one is very simple. It's just a bunch of colored squares applying to different parts of the 3D geometry. Okay, so let's animate the color of the bat. So make sure that your time cursor is at the start of the
There you are.
hurt animation, and click the key next to the color property. It's going to bring the pop-up again, asking you if you want to create a seconds in
I think it's taken a while for the keyframes to show up in the animation
timeline. Then we're going to change the color. So click the color slot to bring up this color picker, and you're going to click and drag until you get a really red color. And you can play with the tones in the circle to change the tint. And then the slider that's vertical on the right controls the brightness of the color. So you want it bright red, like this. You can click away from the color picker to make it disappear, and then click the key icon to insert a new keyframe. And finally, click at the 0.2 seconds point in the timeline, and we're going to click the reset icon, the little loop icon, to reset the color to white, and click the key icon again to create a new keyframe that's white. Actually, if you didn't do that, you can also place a time cursor and click the key icon to insert a new keyframe. And finally, click at the 0.2 seconds point in the timeline, and we're going to click the reset icon, the little loop icon, to reset the color to white, and click the key icon again to create a new keyframe that's white. Actually, if you didn't do that, you can also...
Okay, yeah, so it's just taking a while for it to load.
So place a time cursor at the point you want the keyframe, left click to select a keyframe in the animation, and right click and select duplicate keys. And it's going to create a copy of the selected keys at the point the cursor is in the timeline. And now you can press Shift D on your keyboard to play the hurt animation when the animation editor is visible. The last thing we want to do is to change the length of the animation, because you can see when we press the shortcut, the animation keeps running after the end. To change the length of the animation, you click in the field that's at the right of the animation timeline. So you click that one here, and we're going to set it to 0.2, which is the duration of our animation. And you can click the zoom slider at the bottom right of the animation editor to change the zoom level. With that, we can go play this animation in code when a bullet hits the bat. For that, I want to introduce a new, really powerful node for managing 3D character animation, the animation tree node. It will allow us to layer our hurt animation on top of the idle animation. You'll see that in a moment. So to get started, select the bat model node and click this plus button to add a new animation tree node as a child of it. A new editor appears, though it is empty because we need to configure the animation tree. So let's do that. In the inspector, for the tree root, click and select the animation node blend tree. You'll see the user interface change at the bottom, and I'll explain what this is and what the tree root is in a second. And for the anim player, click assign and select the animation player. Okay, so let me explain. The animation tree node is an editor that allows us to wire different animations and play them in different ways, layering them on top of one another, etc. Okay. So that's why you have to pick an animation player to bind to the animation tree.
I think after this I'm going to have to call it and then work on the rest of this tomorrow.
And what they call the tree root is one of different editors basically that you can use and one of different systems.
Okay, yeah. Yeah, okay, I think I'm done. It's getting a bit late and I'm getting to that point where I'm tired and it's getting hard to follow and I feel like I'm not going to remember this stuff, especially going into animation, which I have a bit of difficulty following. So I'm just going to remember 23 minutes. I left it at 23 minutes on the 23 minutes on the creating mob part of the tutorial. So yeah, good day. I'm going to stitch this all together, upload it, and yeah, a lot of it has just been me sitting and watching a tutorial. I might just upload the entire thing, but I will stitch together my different parts. Like I had my tutorial recap, and then my things that I was doing. So hey, it's all evidence of, you know, training and practicing, getting better. So yeah, that was the 12th of February, 2026. And I will see you another time.